All right, problem number 5. We have a ball dropped from a height of 10 meters, and we want to know how fast it's traveling right before it hits the ground and how long it takes to hit the ground. So let's go ahead, and here's a little cliff. We'll drop the ball from 10 meters. So we have y naught equals 10 meters. We have y final equals 0. We have v naught equals 0. And we have an unknown v final, unknown time, and gravity is negative 9.81 meters per second squared. Let's go ahead and plug in some numbers. So how fast is the ball traveling against it before it hits the ground? Let's go ahead and use a formula that has no time. So v squared equals v naught squared plus 2gy minus y naught. So we're going to end up getting v squared equals 0 squared plus 2 times 9.8 times a negative 9.81, because that's acceleration due to gravity, times 0 minus 10. So everything actually ends up being positive. So I'm going to end up getting v squared equals about 196.2. And so when I solve for v, that's going to give me about 14. Let me just go ahead and confirm that now. And it's about right, 13.75. I think I used 10 for g, so that's not such a good idea. Whoops. 196.2. I don't know why I put 189.2. Yep, so 14.00 meters per second. And let me be clear on this. Before it hits the ground, so this needs to be a negative sign here. So I'm going to need to go back and fix that in Schoology. And then for part B, we want to know how long it takes to hit the ground. So let's do v equals negative gt plus v naught. And we'll have negative 14 equals negative 9.81 times the time plus 0. We solve for the time, and we're going to end up getting 1.43 seconds. So that's it for problem number 5.